Hello friends, today we are going to start a new topic on cement, that is sulfate resisting Portland cement, that is SRPC, and super sulfated Portland cement, that is SSPC. Studying the types of cement is very important because in some construction sites we have high sulfate. So there is a possibility of a sulfate attack. So we need sulfate resisting cements. In this lecture, we will see the properties and compounds involved in this cement. What are those properties which are different from OPCs? The properties differ to different composition of box cement. Like ordinary Portland cement, except that it contains very low C3A, which is less than 5%, and grounded finer than OPC. As C3A is pro-sulfate attack, reduced amount will make cement safe from the sulfate attack. This cement may be used in sewage and canal linings, seawater, coastal areas and marshy lands. Now, in this slide, we will see how this cement will resist the sulfate attack and what are the reactions involved. SRPC is sulfate resistant because the disintegration of hardened concrete caused by the chemical reaction of C3A with soluble sulfates like MgSO4, CaSO4 and Na2SO4 is inhibited. The setting time for SRPC is same as that of ordinary Portland cement. The IST is more than equal to 30 minutes and the FST is less than equal to 600 minutes. The setting time also plays an important role because after modifying the properties, the setting time is same as that of the OPC. The expansion of cement is to 10 mm by the Le-Chatelier method and 0.8% by the autoclave test. The fineness of SRPC should be less than 225 meter square per kg. It can be used as an alternative of OPC, PPC or Portland slag cement under normal conditions. To know how cement gains its strength, or we can say the rate of gain of strength, will be seen right now. The conditions or environment in which the cement is used can be seen along with the compressive strength. Now we see that the compressive strength in the table. So it takes 3 days with a tolerance level of 1 hour and the strength is 10 Newton per millimeter square. For 7 days with a tolerance of +2 or -2 hours, the strength is 16 Newton per millimeter square. Also, for 28 days with a tolerance of plus or minus 4 hours, the strength is 33 Newton per millimeter square. Please keep one point in your mind that the SRPC should be avoided where the temperature is above 40 degrees Celsius or where chloride is present in the environment. This cement is used in many purposes because the sulfate attack is very common. So we must prevent it. Now let us look at the uses of SRPC. It is used in foundations, in piling works, in effluent treatment plants, chimneys and cooling towers, chemical industries, water storage, sumps, drainage works, and also it is suitable for underground works where the sulfate is present in soil as well as water. Now we will discuss about super sulfate Portland cement or SSPC. It is also resistant to sulfates. It is manufactured by grinding together a mixture of 80 to 85% of granulated slag with 10 to 15% of calcium sulfate and about 5% of Portland cement clinker to an extreme fineness about 400 to 500 meter square per kg. It is also prone to sulfate attack but which is limited to 3.5%. Now, what should be the temperature to use this cement? Because this cement is not used in high temperature areas, it can also be produced by addition of extra iron oxide before firing. This combines with alumina which would otherwise form C3A instead of C4AF, which is not affected by sulfates. It should be used in places of temperature below 40 degrees Celsius. Now, what are the properties this cement has with comparison to OPC? The water resistance of SSPC is higher than that of OPC because of absence of calcium oxide hydrate. The frost and air resistance is comparatively lower than OPC. SSPC can be used for mass concrete work as it involves lesser heat. The satisfactory resistance, it provides satisfactory resistance to sulfate attack. As we discuss the rate of gain of strength, so we will discuss about the compressive strength. The compressive strength should be as below. The time for 3 days with a tolerance of 1 hour gives a strength of 15 Newton per millimeter square. For 7 days with tolerance of plus minus 2 hours, the strength should be 22 Newton per millimeter square. For 28 days with a tolerance of plus or minus 4 hours, the strength has to be 30 Newton per millimeter square. Also, please keep in the mind that it should not be used in frequent freezing and thawing conditions. Some important properties have also been discussed. The first one is that it should have fineness which is less than or equal to 400 meter square per kg. Some important properties have also been discussed, that it should have fineness which is more than or equal to 400 meter square per kg. The expansion should be less than or equal to 5 mm. The initial setting time, that is IST, should be more than or equal to 30 minutes. The final setting time FST should be less than equal to 600 minutes. The SSP should not be used with any admixture. It is also resistant to PT acids and oils. That's all for today, students. Please do subscribe to Ekeeda and stay tuned for new updates.